As you may have heard, today a kilogram is no longer defined as we used to define it. I want to go through this entire process with you. I know this is quite a lot of numbers, but I want to go through it because in all of the coverage I've seen of what a kilogram is now, it's all kind of confusing and no one is actually saying what 1 kilogram is anymore. So let's go through this together and hopefully I can explain it just a little bit more, maybe not concisely, but live. So, a kilogram used to be defined as that it was just a cylinder of metal. It was sitting in the basement of a building in France somewhere, and it was just a hunk of metal. And they defined that using a physical object. A kilogram is that thing. And over the years, scientists replicated that thing and sent it all over the world so everyone else could have their own version of a kilogram. Today, a kilogram, the kilogram, is one of the only main units that is defined by a physical object. And the problem with using a physical object is that physical objects can change. I believe this kilogram, which is called in France le grand K, for kilogram presumably, has lost I think 50 micrograms. So a kilogram, the thing, has changed, and yet the definition of a kilogram hasn't changed. And so there's always that problem that a physical thing can change. So what scientists decided to do today in Versailles, France, is to vote to define the kilogram as not something that is a physical thing, but base it on a universal constant of nature. Now, the constant of nature that they decided to base the kilogram on is called Planck's constant, which relates the frequency of a wave of light to the energy of all the photons in that wave. It's a quantum mechanics thing. It can get confusing. All we need to know for this definition is that Planck's constant here is h. And you can see it relates the energy of the photons of light and to the frequency of the light, which is kind of like a little v here. Anyway, this is Planck's constant. Planck's constant is this large number, which is actually very small if you look at the exponent. But as you can see, it is defined with kilograms in its units. Now, with the scientists in Versailles, all over the world, they met in Versailles and voted today, and this is official now. What they decided is that if they determine and set Planck's constant as a universal constant and that's it, boom, this is the value that we're choosing, then by definition, they would choose a value for the kilogram. We have defined seconds and we have defined meters by other universal constants like the speed of light, and vibrations in a cesium atom. So we have constant for all those. We need a constant for kilograms. We decided to set today the value of Planck's constant to an unchanging value. Okay, so that's what most articles will tell you. Basically, what we did is change Planck's constant, and we set it to a value that will stay the same forever, and that will have knock-on effects to other units, other units in science and other measurements and stuff. But for the kilogram, why this is important is that it's no longer defined as a physical object. No other place, though, has told you what 1 kilogram is now. What's 1 kilogram if it's not this hunk of metal? Well, because we have other relationships here, we have E equals mc squared, which you all know, and this is the Planck's constant relating energy to frequency. We can just pick now what 1 kilogram will be based on these constants. And so if you pick a frequency, this exact frequency, actually, 135,639,274 times 10 to the 42 hertz oscillations per second, and you plug that in to this equation with Planck's constant, you get an energy value. And if you divide that energy value by the speed of light squared, you get exactly 1 kilogram. So now we can say that 1 kilogram is equal to the energy, 1 kilogram of stuff. If something is 1 kilogram, that stuff has the same amount of energy as photons, as a ball of photons with this frequency. I know it's kind of esoteric and it's hard to relate this giant number to anything, but that's how we relate a lot of universal constants to other units in science, like the speed of light or oscillations of a cesium atom in a certain amount of time, something like that. So if you use this hertz value, you get exactly 1 kilogram using the newly set and stated Planck's constant, and that is what changed today. Instead of using a hunk of metal, we now have a set Planck's constant, and if you plug in a certain value for hertz, you get exactly 1 kilogram, and that's how we can define that. Now, there's a lot of other interesting science that's happening with this kilogram thing. How do you determine exactly what Planck's constant is, this universal constant? Well, there's a thing called a Watt balance or a Kibble balance, which is kind of just like a scale with the 2 plates on either side, but it uses electromagnets and very, very precise very precise machinery to determine what this is. And scientists have come within a few, between like 10 and 20 parts per billion in accuracy for Planck's constant. And now they feel, yep, we can set it. So they have set it. And the real benefit of doing something like this, by setting a universal constant, instead of just using a hunk of metal, is access. When it was a hunk of metal, you had to, let's just be honest, you had to be a certain scientist at a certain in a certain place at a certain time with a certain amount of wealth and connections. You had to make yourself notariable enough that you had to. That's not a word. You had to make yourself important enough that your lab could get access to one of these replicas or to it itself. People were so afraid to touch this original thing that they only took it out of the box. It was like 3 air chambers, but out of the box once every 50 years. Anyway, access. There's only one of those and a few replicas, and only a few very privileged people get to touch that thing and experiment with that thing. Setting a universal constant now gives the kilogram as a unit. It gives it to all people for all time. It doesn't matter who you are, where you're from, how much money you make, what lab that you're in. Now that this is set, anyone can have access to this kind of precision that only labs that had this thing had. So for all time, for all people, we just redefined the kilogram. And this is one of them. Hello, and that was a very long intro to this, but I think it was important. A lot of people have been asking me about it, and I'm not a physicist. A lot of other people did great videos on it. My friend and colleague Veritasium did a great video on this before it was defined and now after, so go check that out. But this is Because Science Live, the live companion show to Because Science, where I take all of your nerdy questions, comments, queries, and comments about my hair and face and address them live off the top of my head. I don't always know the answer to everything, but I know a little bit about some stuff, so consider me your nerdy conduit to the void, as it were. I have Nate here somewhere.
Yeah, I'm here.
Here is a weird way to, whatever. Okay, so we defined a kilogram. What do nerds have to say?
From Grant Nick, would Yellowstone erupting be an extinction level event, or would humanity be able to survive?
Okay, so I believe the super caldera, I think it's a caldera, which is kind of like, it's just a pit of lava underneath Yellowstone. It's not like the traditional shape of a volcano. It's more like bubbling stuff underground, underneath the surface of the ground. I could be wrong, but I believe it's caldera, and then that's the correct term. But it's a supervolcano underneath Yellowstone, and as far as I remember being told this by Discovery Channel or whatever, and in my studies, is that if that erupted, it would at least be able to severely disrupt life on the North American continent, if not the world. I mean, let's just say I didn't happen to live in the void and I happen to live in, Los Angeles, California. Right now, so many acres are burning in California that blankets of smoke are covering cities and they're having to evacuate and shut down schools. And air quality is so bad that you have to wear masks, can't go outside, people are having health problems. That's just a few acres. A few. It's 100,000 acres of trees burning. Now imagine what would happen if all of Yellowstone burned at once and threw tons and tons of material up into the air for years. You can start to imagine how that would be more of an extinction level thing, incredibly cataclysmic. I don't know if it would mean the end of all life on Earth or that humans would survive. It depends on exactly how big it is and how quickly it happens. But I know that it would be bad. It would be probably the worst natural disaster in human history, probably. Considering how close together people are now and how big cities are, it would probably be terrible. That's kind of a downer. So I want to pivot to one of my favorite games, not this year, last year, the year before, was Horizon Zero Dawn. And they had it's a fantastic science fiction video game. Please play it if you haven't and you like sci-fi stuff. But they had a DLC that was really, really interesting. So in the DLC, scientists in the past knew that this supervolcano was going to erupt. And so what they did is contain it as best they could and use it as something to generate steam. They would pour water on this thing to keep the temperature down, and it would generate so much steam and so much power that it would be like a it would be a steam power plant that would give you so much energy. It would give you just mountains of energy. It's a technical term. So they were actually using the supervolcano to generate energy and also prevent its eruption. And I thought that was just, in a game all about climate change and trying to fix the planet, I thought it was just another incredibly clever thing to do. Man, I love that game. I love it so much. Actually, I can't say anything else about. Never mind. I want to be involved with it. That's all I'm saying. Okay. I want to be involved with I'm a greedy guy. What's next?
From Heather Selset.
Hello, Heather. Live.
If you could go back and do footnotes for any other older episodes, which one would you want to clarify on the most?
That's a great question. If I could go back, so we launched this channel powered by Nerdist, but this is just used to air just on Nerdist YouTube. So there are like 4 years of 4 years of Because Science videos before this became its own channel. We only have, what is it, 25? 20, 30 videos on here, so 20 to 30 footnotes. And that I use footnotes to go back and kind of like Mythbusters used to do, and do updates to things like, oh, I got this wrong, I think I got this right, this is what you said. What episode would I go back that I haven't to correct or add commentary to? Well, there's never quite been a video where I thought something was so wrong that I had to take it down. I try to stay within my areas of expertise and things that I feel comfortable talking about. It's never been quite that bad. Although, I think one that I may have kind of missed the mark on is why don't lightsabers burn your hands off when you turn them on? And my idea was that they were kind of like experimental fusion reactors that we have that contain very, very, very hot plasma within toroidal, like Taurus, toroidal magnetic fields. And I said that if it was like that, the heat would not escape these magnetic confines because you'd have to actually touch this gas. But if it was that hot and it was able to cut through rocks like Rey does, or cut through a door like Qui-Gon Jinn does in the Phantom Menace, then these lightsabers would be giving out so much radiant heat that even if they were magnetically confined, the plasma was, it would still probably burn you. And what I forgot was that in these experimental fusion reactors, they try to have a vacuum around the plasma, so there's no air to transmit some of this temperature. And someone pointed that out to me, and yeah, I think I'm not quite on the mark there. Although I have to go back. I don't know if I'm totally wrong, but I've heard it put that in an experimental fusion reactor, a tokamak, like I always compare lightsabers to, it is so hot in the plasma, tens to hundreds of millions of degrees, I think, that it is so hot in the plasma, and then it's room temperature outside of the reactor, right? So it's just like a meter of space in between tens of millions of degrees and normal room temperature degrees. And I've heard it put that is the largest temperature drop in the universe, based on distance. To go from tens of millions of degrees to, relatively speaking, zero comparatively, that in just 1 meter is the biggest temperature drop in the universe. And I think it's awesome that humans are smart enough to do that kind of thing. Okay, what's next?
From Scott.
Scott.
If you could add any natural ability found in another animal to humans, what would it be?
Any natural ability found in animals. See, I wonder. I mean, a biologist or someone much smarter than myself could probably answer why humans were taken out of the evolutionary arms race in the predator-prey kind of relationship like that, where cheetahs get faster, gazelles get more agile, they get claws get sharper, teeth get stronger, legs get bigger. All in this evolutionary arms race to be the fastest, the strongest, to eat the most prey, to pass on your genes the most. Humans, with our big brains, probably removed ourselves from that daily violence, and so we don't have giant claws and giant canines, although they're kind of still there. But I'm just speculating. That's more of a biological question. But if we had to have something more in that evolutionary arms race, what would it do? I would... You know what I would like? Despite what I may appear, I have to work very hard to engage with people and to try to be charismatic and interesting. I've come up with a lot of good coping mechanisms for it, but it's definitely something that I have to work at and do. And because of that, talking to people isn't my number one favorite thing to do in the world. I'll put it that way. If you want to talk to me about something, sure, let's talk about cool stuff. But usually my default mode is just chilling. So if we could give humans any animal adaptation, I would like to have the chromatophores and cellular machinery so that I could have the kind of camouflage abilities of a flamboyant cuttlefish. And not in the way you think. I wouldn't just fade into the background so no one could see me and talk to me. Although that does sound good. What I mean is, I would like to be able to change skin color, make pigmentation change, and texture change and everything, so you could, like flamboyant cuttlefish do, my favorite animal, like they do, you could make your skin flash and flare up and change texture as a signaling mechanism. And so you could talk to someone without even opening your mouth. That sounds good. And then you could also, make yourself look like a checkerboard. What's next?
From 0.
Ooh, like at 0?
It's XERO.
I was gonna say, there's no way you got just 0, dude.
Yeah. How long can you survive on a cannibalistic diet?
Hey, how you doing? Asking for a friend who's very tasty? Anyway, cannibalistic diet. So I mentioned this on a footnotes before, but people have done studies on the calorie content of people just to see how viable cannibalistic tendencies would be in gotta put this the right way, in ancient humans. Yes. So cannibalistic tendencies, is it a viable way to live aside from, hunting prey? Now, I don't remember the calorie content values off the top of my head, but I do know that humans have a lot of calories to offer if you're eating the right things. Large muscles, brains can be very nutritious as long as they don't have prions in them, and they can give you spongiform encephalopathy, which would, kill you. But brains, muscles, bone marrow, there's a lot of tasty, tasty stuff in human meat. And there's enough in one person that it could sustain you for a while. And I don't know if it's, 1 day or 1 year, it's not gonna be a year, or a few weeks, but it's a few days. There's enough calories in a person. If you need 2,000 or so per day, if you're the average size human male, or a little bit less if you're female, you can get a few days worth of calories out of one person, I think. You probably want to also cook them, or pieces of them. Going down a dark road. Speaking of dark roads, we know that you can survive for a little bit of time being a cannibal, because there have been cases. I don't know if you all had to read this when you were a kid, but I did. That case of, it was in psychology, my psychology class, is that case of, I think it was soccer players or rugby players who crashed in the Andes Mountains, and they were on a mountainside for like 50 to 70 days, like a month or two, something crazy, and the only food they had was the people that died in the crash and other people who died afterwards. And they lived. And they had to come up with, what's really interesting about it is that they had to come up with different social rules for the situation. They couldn't bring themselves to eat their friends and their colleagues, which is horrible, until they started to redefine the social context and say, this is a different situation, different set of rules have to apply. We have to start thinking of these people not as our friends, but as a way to sustain ourselves. And then they were able to survive in a very harrowing tale of human survival. So yeah, you can survive more than a day on human meat. Man, I'm walking a very fine line here between too dark and too weird, but it's all interesting. What's next? Give me another tasty question.
From Dat Penguin.
Ooh, that penguin?
No, Dat Penguin.
Dat penguin? I like that one. Looks like he's wearing a little tuxedo.
What are the limitations of living on Venus?
Well, I think Universal movie That Can't Happen scientist Neil deGrasse Tyson once tweeted, taking shots, tweeted that I think a large pizza can cook on the surface of Venus. Am I thinking of Mercury? Uh-oh. Anyway, punting. An idea to live on Venus. I don't know which one's I think it's Mercury that's the super hot one, or is it Venus? Anyway, they're both hotter. Okay. Venus, I think the idea that NASA had and studies were done on if it would be possible to live above the Venusian surface, above the thick atmosphere in like Cloud City, a Cloud City-ish situation where the atmosphere is thick enough that you could float stuff on top of it or put stuff near the atmosphere. You could live above the hellish surface. How viable is that? No idea. That is, I think it's completely theoretical and beyond our lifetimes. I mean, the technology to establish humans on another planet is in its infancy at best right now. So to not just land someone on, live on the moon in a colony or live on Mars, stuff that it's a surface, we're familiar with that, but to live in a much less hospitable place like Venus, I don't know if that's viable within our lifetimes even. I don't see technology or people pushing for that kind of thing. I think Mars is the real target right now. But ask an astronomer or an exobiologist or something. They'd have a better one. Kevin Hand on Twitter, Astro Katie on Twitter, both very intelligent people who might be able to answer that question for you. Free plugs. What's next?
From Scott Powers.
Scott Powers, detective at law.
How does magnetism work?
What? Okay. I think your question is magnets. How do them work? And this is a very physics-heavy question that I may not get right off the top of my head. Again, friend and colleague Veritasium and Minute Physics did a collaboration where they answered what magnetism is in detail, so go watch those videos. But in my attempt to summarize what magnetism is really cool in that it is an expression of a quantum mechanical effect at macro scale. Usually, quantum mechanical effects kind of cancel themselves out by the time they get to the size of us. Going back, this is a quantum mechanical constant used in a lot of calculations. Look how small that is. Minus 10 to the minus 34. Trillionth of a trillionth of a 100 millionth or whatever. Trillionth. So this is really about that. This is really, really small. And quantum mechanics deals with stuff that's really, really small. So usually when it gets up to our scale, these little tiny effects cancel out, and we don't see human-sized things tunneling through walls or being superimposed in all possible states, that kind of stuff. But magnetism is an expression of this, and it's because the chaos is aligned. So in something like a permanent magnet, like a permanent magnet that you can just stick on your refrigerator or something like that. Instead of having all of the particles in it, which can act like little magnets, just with all the electrons and stuff, instead of having all of those facing the wrong direction, so that the little magnetism that they would put out cancels out, permanent magnets have all of those particles oriented in the same orientation, not in the same plane, but they're all facing the same direction. And when that happens, all of those little magnets add up into an effect that we can see at our scale. Usually, things that aren't magnetic at all have those same particles, but they're all over the place, facing in different directions. It's not lining up to produce a larger effect. In permanent magnets, all of those little particles are lining up in just the right way, so you can see this quantum mechanical effect, and we see that as magnetism. Things that aren't permanent magnets but can be induced to be magnetic, like if you've ever run a magnet over a certain kind of nail and it becomes like a little compass in your water, those, in the presence of a magnetic field, if you run the permanent magnet over it, parts of that material can realign themselves with the magnet, with the permanent magnet, so now they have enough of their particles doing the same thing, so now they are kind of magnetic. So magnetism is a macro scale view of a quantum scale effect that everything has, but only certain materials show because of the orientation and the positions of all those little particles. I believe that's a rudimentary answer to that, but again, if you want to search for it with the videos that I mentioned, they go into much larger detail, but I think I'm pretty much on it. Whew! That was a lot of long-winded conversation today, but a lot of great questions. I hope this made sense. Thank you so much for joining me on this edition of Because Science Live. Whew. It was a week, but we have a lot of great content coming to you next week. New vlog, new live stream, new episode. We had a lot of content this week. 2 videos for you. How about that? Go check it out. Fallout laser video, how strong can they get, and which starter Pokemon from Generation 1, you Pokedex people, is the most powerful starter you can pick. Whew. Got a lot of nerdery coming up for you up until the end of the year. It's going to be great. Thank you so much for joining me. Have a wonderful weekend. And remember, just like the scientists wanted to redefine this so we could have something for all time, for all people, realign yourself to something like that kind of thinking. Be for all people. Be nice to everyone. Consider everyone, because this is all we got.